physical quantity? The very first question that comes in our mind is what is physical quantity? So we'll understand it today with example. Physical quantity is nothing but the physical property of a material or system that can be quantified. That is, that can be measured using numbers. So physical quantity is nothing but anything which can be measured. Let us consider this man. Let the height of this man is measured in length. Let's say the height of this man is 2 meter. Now remember, physical quantity is nothing but magnitude with its suitable unit. So you can say that physical quantity we can classify physical quantity into magnitude and its suitable unit. So 2 is the magnitude and the suitable unit for the magnitude 2 is meter, which is the unit to measure length. Let us understand this physical quantity with more example. Let us start with time. We measure time using clock. Let's say the time is 2 minutes, where 2 is the magnitude and minute is the unit for the time. Mass. Let's say mass of this watermelon is 2 kg, where 2 again is magnitude and kg is the suitable unit of mass, which is kilogram. Temperature. We measure temperature using thermometer. So 2 Kelvin, 2 is the magnitude and Kelvin is the suitable unit to measure temperature. To understand physical quantity in more details, let us see what is not physical quantity. So you can see the number which is 16, 17 and 18. These are just the number, there is no unit. Now see this number as 16 meter, 17 second and 18 kg. So these are the magnitude along with the units. So these are the physical quantity and the numbers with no units are not physical quantity. Physical quantities are majorly divided into two categories. The very first one is the fundamental units and the derived unit. Let us see one by one. Fundamental unit. The physical quantities which do not depend on any other physical quantities for their measurement is nothing but fundamental units. Example is length. You don't have to depend on any other unit for the unit of length. We know length is measured in meter. Now the derived unit. The quantities that can be derived from the fundamental unit. Example is speed. There is no proper unit for the speed. We derive it from the fundamental unit because speed is nothing but distance upon time. So unit for speed is meter per second. Let us see more in details with the fundamental unit. Fundamental units are also known as base unit. There are seven fundamental units that we see one by one. The very first one is length, which is measured in meter using meter rule. Mass, which is measured in kilogram. Time, that we measure using clock or stopwatch, is measured in second. Electric current, which is measured in ampere. Temperature is measured in Kelvin. Unit for amount of substance is mole. Luminous intensities can be measured using candela. Derive unit. Now the derive units. Let us start with force. Along according to the Newton's law, force is nothing but mass into acceleration. Unit to measure mass is kg and acceleration is meter per second square. So meter kg meter per second square is nothing but Newton. Velocity. As we know, velocity is nothing but distance upon time. Distance is measured in meter and time in second. So unit for velocity is meter per second. Followed by density. Meter mass upon volume, that is kg per meter cube. Then power. Power is nothing but inner. Next, we'll start with the measurement techniques. Now, measurement techniques are essential for the accurate scientific investigation. With this technique, your investigation will not only be accurate but also known by the world. There are some instrument which is used to measure this various parameters that we'll see one by one. The very first one is the meter rule. These are employed to measure distance and the length. We are very much familiar with the scale, which is the meter rule. Okay, that is used to measure various length and the distances. Second is the balances, which is used to measure mass. Now, the balance can be used to measure mass. You can use the beam balance or the weighing scale. Anything that measure mass will come under this instrument. Third is the stopwatch. So we need stopwatch to measure time. Now, time can be measured in second, minute, hours, or days. Next is the ammeters. Ammeters are the instrument that is used to measure the electric current. The ammeter is used to measure the amount of the current. If you will see the figure, there is one needle into the figure. Now this into this device, the deflection of this needle will give you amount of current. Same as ammeter, voltmeter is used to measure the potential difference across the circuit. The instrument for the voltmeter looks like this, which is very much similar to the ammeter. Now, what about very small length? What about very small measurement that your meter rule doesn't allow? So for such small length, we use vernier caliper. Vernier calipers use a sliding vernier scale to measure the distances, diameters, and thicknesses. Vernier calipers typically have the resolution of zero point 0.1 millimeter or even smaller. So a normal meter rule will give you, let's say, zero point 0.1 centimeter reading, but the vernier caliper can give you less than that. This is how the vernier caliper look. If you will look into the figure, there is one main scale, one vernier scale, and there are two jaws. The lower jaws is used to measure the outer dimension of the object, and the upper one is used to measure the inner dimension of the object. All you have to do is just place your object between these jaws, and then you can check your main scale and the vernier scale reading to get the measurement of that object. Let us understand this with this figure. If you will see this figure, the object which is nut is already placed into the jaw. Now see the 0 of your vernier scale that exactly coincide with 2.4 of your main scale. Your main scale reading will be 2.4. Now how to take a reading of the vernier scale? All you have to do is just see which line of the vernier scale exactly coincide with any of the line of the main scale, and that division will be a vernier scale reading. Here in this figure, you will see the seventh division exactly coincide with the main scale reading. So the seventh division, 7 into least count of the vernier scale, which is 0.01, so you will get 0.04 as your 0.07 as a vernier scale reading. And just so have to add mean scale reading and a 1 year scale reading, you will get your answer. One more example over here is the main scale reading is 11 and the 1 year scale division that exactly coincide with the main scale is second division. Now here we multiply it by 0.01. Least count of every devices is different. before using any of this instrument, you have to check the least count because they can be different. The previous example that we did, the least count was 0.01, and for this example the least count is 0.1. So you will multiply your vernier scale reading, which is 2, division is 2, multiply it with 0.1, and you will get your answer as 0.2. Now for the final reading, you just have to add your main scale plus vernier scale reading, and you will get the exact answer. Okay, now what about the diameter and the radius, the small diameter and the radius that we cannot measure this with a vernier scale. So there is another device known as micrometer screw gauge, which is used to measure the diameter of a thin wire, thickness of a small sheet, or such as glass or plastic. This is how the micrometer screw gauge looks like. If you can see, the object is placed between the spindle. There is two scales over here, main scale as the vernier one, and there is one timbal scale, which is also known as circular scale, because this rotates in a circular direction. All you have to do is just wrote out the reading of the main and the vernier scale, and you can get the diameter of the small object. Formula is main scale reading plus timbal scale reading. Let us understand this with more example. Over here, if you can see, the main scale reading, let's say this is about which touches your timbal scale at 10, 11, 12, and that is 13. So the main scale reading is 13 millimeter. Now let us check the timbal scale reading, which is after 40 there is one division, so that become 41. Multiply it with the least count, add them, and you will get your final answer as 13.41 millimeter. As I mentioned before, the main release count can be different of different devices, so it's very important that you look at the release count first before using a device actually. Now see this one. After 5 there is 6 division. The timber scale reading meet the main scale reading at 6, and the division for the timber scale is after 40, 1 to 3 lines, so that will be 43. So main